So, in today's session, we are going to cover a quick overview of the manufacturing sector, a look at opportunities in this sector, and I'm going to introduce you to our two experts for today, Daniel McMahon and Graeme McLaughlin from NMIS. We'll give you a chance to ask our experts some questions, and then we will conclude the session. So please get involved as much as possible. Use the Q&A box at the bottom of your screen to ask us questions as we go through the session. We'll try and answer as many as possible, but we might not get through all of them today. I would just like to let you know that today's session is being recorded so that young people who could not make it today can still access the resources. It will be available for everyone to watch on the My World of Work website and YouTube channel. That means you can go back, watch it whenever you want, and see what we talked about today. Don't worry, everything you ask today will be completely anonymous, and you can select the option through the Q&A box. So just before I introduce you to today's experts, let's have a look at the manufacturing sector. The manufacturing sector is a vast industry, and it spreads into so many different sectors and industries like aerospace and space, climate and energy, life and chemical sciences, construction, and so many more. It takes place in almost all regions of Scotland, with medical manufacturing taking place in the north of Scotland and satellite and spacecraft manufacturing taking place in the central belt. But those aren't the only types of manufacturing that take place in those regions. As I said, it's such a diverse sector and industry. It takes place in different industries, different sectors, and that means that there's so many different products being made in Scotland a year. In fact, there are about 190,000 people in Scotland in the manufacturing industry, and they produce about 50% of Scotland's international exports. So we're going to introduce you to Daniel McMahon and Graeme now from NMIS, National Manufacturing Institute Scotland. So can you give us an idea of who you are, guys? What do you do and how do you do it? How did you get to where you are? We'll start with Danny.
Morning everyone, I'm Danny McMahon. I lead the digital manufacturing team at the National Manufacturing Institute Scotland. Digital manufacturing is really an emerging industrial revolution, the way we're looking at it. So it's about connectivity and really connecting up all of our devices into an industrial Internet of Things, and then using the data that network provides to provide insight and get intelligence out of our manufacturing systems. But really, my team covers a broad range of technology areas, from metrology, which is really high precision measurement, how we measure all the products that we make, so that they can actually build into other systems and assemblies. We cover robotics and automation, data analytics, industrial Internet of Things, visualization, so like virtual reality headsets, augmented reality, and how we look at data and an extended reality type of format. So I mean, a day in my life is really quite broad and takes me into a lot of different technology areas. I got into engineering through an apprenticeship straight from school. So an apprenticeship back then, it was a craft apprentice. So first year from school straight into college for the full academic year, where you really learn a bit of a foundation of what engineering is and some of the disciplines that you'll use when you go into the factory. So in that year we gained an NC, a national certificate. We then progressed into the factory where we worked day to day on the shop floor with all the other engineers manufacturing aerospace components. So you could be mostly metal forming and cutting is what we've done. So you could be on a forging press making aerofoils, you could be on a CNC mill or lathe or grinder cutting metal. So it was a real interesting place to work. You're getting that hands-on practical experience, which then you evidence, and that turns into your Scottish vocational qualification, which is your practical qualifications that go along with an apprenticeship. We then went back to college for 2 years on a 1 day a week day release basis. So you were in the factory 4 days a week and you were at college 1 day a week, so that you were still keeping up that education and the academic side of things. And over that 2 years, we've done an HNC, a higher national certificate, and we completed our SVQs. And all of those things together is what gives you an apprenticeship, where you become a time-served apprentice into manufacturing. So when I completed that, I'd done quite well. Obviously, you know, going from school to college was an easier transition for me. I'd done quite well at college, and I really felt like I fitted in engineering. So at the end of that apprenticeship, there was an opportunity to be sponsored through a degree, which I jumped straight into. So the company I was working for basically paid my university fees. They continued my day release, so I went to university 1 day a week for 4 years. And that was really hard work, because university is such a step up from school or college. You really need to have that drive, because you're no longer in a teaching environment, you're being lectured at, so it's your responsibility to learn. So that was an adjustment, and I think if I'd gone to that straight from school, I would have struggled a lot more, but having that college and apprenticeship in between kind of prepared me for that transition. So that 4 years was really hard work, doing that 1 day a week, but I completed that. I gained an honours degree. During that process, I actually transitioned from working on the shop floor to being more office based and more about a technical engineering leading type of role for the manufacturing production lines. And I started to specialise in metrology, which I touched on earlier, which is a high precision measurement. So I was responsible for a lot of the measurement in the factory. I then, after a couple of years of just working, I felt I kind of missed the education side, because it's quite an intense experience doing the day release degree. So I actually volunteered to go back to university, which there was times when I thought, why am I doing this? Because it's really hard work doing it 1 day a week. So I went back and done a master's degree. That was only 2 years, but it's a lot more self-directed research and learning. So it's quite a different experience again. But it was really good and enjoyable. Again, I achieved my master's degree in 2015, and at that point the opportunity came up to join, at the time, the Advanced Form and Research Centre, which is now part of the National Manufacturing Institute. So I moved across, which was fortunately just next door for me, so it didn't really change my commute too much, and I took up the position to lead the metrology team within the AFRC. So that meant running a metrology lab, looking at all the equipment that we use, and basically controlling all the measurement that went through that building. So it was more of a research and development environment, where we do industrial research for large and small manufacturing companies. So it was a real varied work that I was seeing in terms of the parts we were measuring compared to what I was used to. So again, it was a bit of a transition, but it was a real interesting place to work. That then developed into what is now the National Manufacturing Institute, and the digital team started to emerge as the digital technologies were becoming more and more used through engineering. So there was a lot of similarities between how we measured parts. So we would essentially reverse engineer a part using 3D scanning techniques. Some of them are photogrammetry or structured light, where we basically scan the parts. It seems a little bit sci-fi. You scan the part with light and cameras, and you essentially get a 3D model of the as manufactured component. And then because it's so accurate, you take measurements from that 3D model. And that is a lot of what digital manufacturing was, you know, having that digital twin of a real physical artifact. So because of those similarities, I took on leadership of the digital team as well, and that's now grown significantly. So we now have quite a large team with a real broad skill set in the team. I've recruited engineers, I've recruited software developers and people from a games development background. I've got data scientists. It's a real cross-functional team with a lot of different skill sets in it, and that makes my day really interesting. So that's just a little bit about me, an intro to my background, and I hope you've got some questions later, and I'll do my best to answer them.
You've had such a really interesting background, and it's really nice to hear that your team's made up of people of all sorts of different backgrounds and skills. So it just goes to show that anyone can really fit in manufacturing, depending on your skill set.
Yeah, absolutely.
So I'm going to pass over to Graeme now, and he's going to give us a wee bit of information on his background and how he got into his position and a wee bit about that. So on you go, Graeme. The floor is yours.
Thanks very much. Well, hi folks. My name, as introduced, is Graeme McLaughlin. I work within the NMIS, National Manufacturing Institute, within the design engineering team. I lead up what's called the product development team within that team. So that's helping our clients, develop their concepts or ideas they might have and begin to mature those into products that they can then take to market, and then obviously, hopefully, generate income for their companies and help to create jobs. So that's kind of the focal point of what I guess I do within my job, and a lot of the day-to-day, how you go about doing that, because you're developing products, there's a whole bunch of different areas to consider. There's the actual skill sets of, doing the mathematics, the physics, understanding how something works, designing within those parameters. There's using things like CAD, so it's the computer-aided design software, that I'm sure many of you will be familiar with from high school. And using those tools to begin to make and create designs and realise people's products ultimately, and helping them with, I guess, my expertise and the experience from the rest of the team that we have. We have a bunch of engineers in the team that come from a ton of different backgrounds, whether that is aerospace industry, working for consultancies that designed the engines that actually go on Rolls-Royce Rolls-Royce engines that go on Boeings, etc., or that is oil and gas industry, and even speakers. We've got a guy in the team who works for a speaker company. So there's a whole range of skill sets there. Some of that really in industrial design, which is like looking at how aesthetically things look, right down into the kind of more functional, high integrity stuff, which is a lot more where I'm focused and what my background is. So unlike Danny, I didn't take the college route coming out of school. I decided I wanted to go to university. I don't know what the kind of guidance you get nowadays is with that, but obviously I had a careers advisor that I spoke to at the time, and I talked about my interests, my passions, and they were like, "I think engineering sounds really good for you. You should maybe look at that." But I didn't really know what to do, if that was going to be mechanical engineer, chemical engineer, and I found all this stuff really interesting. Decided to go mechanical, went to Strathclyde University and did my master's degree in mechanical engineering. That's a really interesting course. It's as Danny says, you come out of school and you're taught, but when you go to university, it's all about you actively going to learn, which means the onus is on you. You need to take the time to spend to go through the material you're given, to go through tutorials and stuff. But it was a really great experience, and it really worked out very well for me. Coming out the back of university, I went into what's called a graduate program. So basically, I was employed by an oil and gas equipment manufacturer. And what they did was they took me through what's called a monitored professional development scheme. And basically what that is they put you in different bits of the business, so you get to see all the different functions that support the business to deliver their product. So I came in as a design engineer with a view to being part of that side of the business, designing equipment, but they let me see what project management looked like. They let us see what the quality side, making sure parts are actually made the way they should be made. They let us actually get hands on the tools, so actually making equipment, so seeing the bits that we would design and actually get a chance to put that together, so you get to see all the mistakes that you make during the design process so that you can make it better the next time, basically. That was a really great experience for me, gave me an opportunity to develop a lot, and coming out the back of that, I went into my design role for a few years. I ended up leading a design team, designing really high integrity equipment that basically is like to simplify, it's like a tap for oil. A lot more complex than that, but ultimately that's what it is. It sits at the bottom of the sea, so a lot of design equipment there. Had the opportunity to follow this equipment across the world. Went to places like Norway, Angola and Africa, get to follow offshore and be on a rig. So that was a fantastic experience. So not just doing design, getting to see the manufacturer, getting to see the delivery of that equipment at the coalface, as I say. Following on for that, an opportunity came up with NMIS, and I was getting a bit of itchy feet in my work, so I decided I wanted to try something different. There was an opportunity for our design engineering team, which when I started, there was literally only one other member of staff. That's now beginning to grow. I think we have 9 team members now. basically, like I said, we're focusing on supporting clients develop the products, and similarly with all the things that Danny touched on, there's a lot of digital technologies that we're using to support with that, and that's becoming a bigger and bigger part of what we do. And obviously now we're all working from home, so we're having to engage people a lot over things like Teams that you're watching us on just now, but it also means you're having to design in that digital environment. So a lot of these digital skills you're learning in a lot of other areas apply to design engineering, and ultimately lead on to creating and manufacturing products. So that's a whirlwind tour of I guess where I am now and how I got here.
You've both got such interesting backgrounds, and I think it's a really good point to make about speaking to your careers advisor, because like they can really help you find a career that suits you and that you're interested in. And it was really interesting to hear that you've been all over the world with your career, and I think it's nice to get out of Scotland and collect more experiences and then bring it back. Oh,
definitely. I was very lucky, and it's just when you get these opportunities, you need to take them, right? And it's fantastic getting to see the impact of the things you design, and that's why I love engineering and manufacturing, because you get to make real things, and then you get to see those real things in action.
That's such a really good point. So we do have a couple of questions coming in now. We've got one for Graeme while we're on you. What made you choose this career?
So I guess, like I said, during school I was really interested in things like physics and mathematics. Just that stuff really made sense to me. I'm really like a numbers, process orientated person, so making sense of the world using those tools was really appealing to me. Like I said, I spoke to a careers advisor who kind of guided me down the path. Maybe engineering would be of interest to me. I went to Open Days, which I really recommend if you're interested in going to university, and I think colleges do these as well. Highly recommend you go to Open Days for universities and colleges, because you get to learn about what the courses offer and get to see if it's a good fit for you. And what's really good about those scenarios is you get to speak to people who are doing the courses as well, so they give you a bit more insight into whether or not it's something that might be appealing. That was all the information, kind of the back end of things that informed it for me, and decided that was the kind of route I wanted to go down. I like the idea of getting to design things, and like I said, getting the idea of actually making things. It'd be a physical thing at the end of the day. But where the inspiration came from, I suppose, was from a family perspective. There's always been sort of engineering in my family, so that just kind of motivated me to go down that route. So there's always a bunch of different factors in everyone's lives that kind of I guess influence the route they take. But the biggest thing I can always encourage people is find something you're passionate about, something you find really interesting. I always find design, I find engineering-y things. I'm always reading stuff on the internet about engineering. So you find the thing that makes you want to read more, and that's the type of thing you should start looking at for your career.
That's a brilliant point. Find something that sparks an interest in you. I really like that. Danny, we've got a question for you. Industrial Internet of Things is a weird name. What does that mean?
It is a bit of a weird name, but it's so ubiquitous in my day now that I forget that it's not as commonly known. I'm going to go out on a limb and say most of you will be familiar with the internet based on what we're doing right now. The internet was basically designed as a tool to share data when it was first started, and it was around research, being able to share data across the world so that people can benefit from good research and knowledge creation that's going on around the world. Now, you'll consume that data day to day, whether you're on Facebook or Instagram, or you're shopping for a new pair of trainers online. That is all data sharing. It's connecting you with information that you need from somewhere else to carry out a purpose, whether it's keep up to date with the news, keep up to date with your friends, or to go shopping. So the industrial internet of things kind of builds on that, where we have a huge network of manufacturing equipment, and each piece of the equipment plays its part in your manufacturing system. And within those manufacturing bits of machinery, they all have their own data, so they're all doing things, and they're controlled in certain ways, and it's a very data-rich environment, but we don't always use that data to the best that we could. So what we're trying to enable through the Industrial Internet of Things is to connect those machines up, much like the way your smart devices are connected. So if you're on your PC at home and you're looking up a pair of Nike trainers that you want to buy or get for your birthday, and then later on that day you're on your phone looking at Facebook and an advert pops up for those exact same trainers you've just been looking at. That's not coincidence. That is a targeted advert, because you have a digital twin of yourself that exists online through your various logins and your devices. So the internet actually knows quite a lot about each of us as individuals. In that way, it can provide us content that's individual to each of us, regardless of what device you're using. So it can really track you in quite interesting ways. So if we could apply that to manufacturing, where we understand what's going on in all of our manufacturing devices, we can see that a machine is behaving differently from how it has historically. So we're starting to track behaviours and looking at, it's actually drawing a little bit more power from the socket in the wall than what it usually does. That could mean the motor's starting to wear down, or the bearings are starting to go because it's having to put more power to equal the same performance. So there's trends like that we can look at through data, and it means that we can go and do maintenance on that machine before it actually breaks down, instead of doing reactive maintenance when your car breaks down, you're stuck at the side of the road. Now imagine before you went on that journey, you knew something was starting to fail in your car, you could go to the garage, get it fixed, and you knew your journey would be fine. It's having that kind of predictive nature is what the Internet of Things, or the industrial Internet of Things, is going to open up. And that brings a whole load of different disciplines into the manufacturing skill set, which is why in my team we have, data analytics and data scientists. We have people that do integration and connect devices up. We're even working on some more of the IT type infrastructure, so looking at networks. How do we move that data from the machine to a server where we store it and can analyze it? We're looking at potentially using 5G and mobile networks as a way to move this data around. So just that small phrase, industrial Internet of Things, in the internet that you're all familiar with, that brings a huge challenge to manufacturing. Opens up huge opportunities for bringing in different skill sets and getting much better efficiencies. It's all about trying to drive better performance and efficiency out of the manufacturing assets that we've all invested in.
That's so interesting. It's kind of like we're teaching equipment how to teamwork with us and how to tell us when something's going wrong. That's really cool.
Yeah, it's self-learning systems is where we're going.
That's fascinating. Graeme, we have a question in for you, and I think we could maybe give this to Danny afterwards. What's your favourite thing about your job?
I guess ultimately at the core of it is doing something creative, I suppose. Having the opportunity to take the skills that I spoke about, all those kind of analytical skills and stuff that I've developed, but actually use them in a creative way, which sounds kind of counterintuitive, but in design it's all about creating boundaries for things. You create like a box within that a design has to work within, and creating those kind of restrictions, but coming up with something creative in that space is the most interesting thing for me. Because it relies on so many things. It relies on access to tools, and whether or not, if that's cutting edge equipment, and suddenly that box becomes a little bit bigger because your opportunities are a little bit better because you've got more capability, or you go learn a new skill set and suddenly you can do something else for a client or for a product, and it's speaking to colleagues who've got experience to help you inform those decisions as well. So it's all for me. It's always been creative, getting a chance to turn my hand at a design challenge and come up with a solution.
I really love that, because I think a lot of people get this image in their heads when they hear manufacturing, and they think, oh, it's just a construction line, but it's so much more than that. You get to use your brain and solve problems and communicate with people to get to an end product that you're all happy with. And yeah, that's really cool, Graeme.
Definitely, engineering's just problem solving at the end of the day. There's always a problem that needs solved, and
Exactly.
typically it's an engineer that seems to do it. So
that's brilliant. Daniel, what is your answer to this question? What's your favourite thing about your job?
So much as Graeme says, my favourite thing is about problem solving. I love a challenge. I love doing puzzles. I was always kind of interested in maths at school, because you could always calculate a definite answer, whereas some of the other subjects could be a bit more subjective, where you could maybe argue different standpoints. I liked having this is the answer, and a route to calculate that, and it actually means something in the world. the thing with doing maths at school was I couldn't always relate it to the real world. But when I went into engineering, it started to fall into place. I understood, you know, what I was calculating, how I could apply that in work and what it meant. So problem solving is definitely a big part of it. But the other thing that I really like about it is it allows me to be creative, because working within innovation and engineering and problem solving, it's a real creative skill set to come up with new ways of using technology and new ways of doing things, and how you look at something that, you know, there's a whole load of engineers around you and something's not working and they're looking at you to fix it. That can be quite a challenging environment to be in, and quite a bit of pressure, especially when there's a production line stopped, and every minute that's stopped, it's costing money. So those pressure situations, when you actually go and everyone's looking at you and you fix that, the satisfaction that you get from that's incredible. But I always looked at like the arts. I always wanted to be good at drawing. I could never draw. I love music, and those sort of artistic people I always looked at as being the real creatives in the world, and I wanted to be creative. And engineering allows me to be creative, but in a way that works for me, because I can't draw, but I can do CAD, so I can design things and make good drawings electronically, but I could never ever draw them freehand. So it's things like that that just allows me to explore the things that I like in the world in a way that is accessible and kind of easier for me to do than to be an artist or whatever. I can, you know, get involved in designing products. I can make them and get an actual physical thing. There's quite a lot that is my favourite thing about my job, but the main thing is problem solving, because even when I come home at night, I'll sit and do problems and, you know, sit and do Sudokus instead of watching TV. That's just what I like to do.
That's so interesting, and it's a really good point that with maths and physics and more technical subjects, there's still creativity involved in that. Like, there's creativity in finding that solution in your own way, and there's creativity when you're using CAD to make a building or make a product, or just in exploring to see what you can actually make. That's brilliant, Danny.
Yeah.
I really like that. While we're on you, you mentioned VR and AR from a work perspective. Can you explain these a wee bit more?
Yeah, no problem. So I mean, they are gaming technology. We use the same consumer technology that you would if you're playing a computer game at home. But what we do with it is we put a bit more serious data into it. So we do Unity. Unity is a software that is a physics engine that if you've played computer games and, you know, you're in a racing game and you crash your car and the car deforms, that's physics essentially, because you've got F equals ma and the material Young's modulus. You know how that should behave. I know I threw out a few words there that are a bit odd, but don't worry about that. The main thing is Unity is a physics engine that captures how materials and things behave in the real world and can simulate it. So when you apply that to engineering, it means that we can try out manufacturing processes, we can try and deform metal, and we can do it all virtually in a VR world. So that saves a huge amount of money, a huge amount of time. We can essentially do trials without having machines. We don't always get it 100% accurate, as you've probably seen in computer games when you play them. Some of the physics is a bit weird, but it means we're maybe 80–90% of the way there by the time we go to the machine and we're actually using real material and real equipment, and it's costing, you know, real money. So it's a big enabler for trialing a lot of new things. And the immersive part in it is really, you know, a bit of a design tool, a planning tool. So the FRC and NMIS, we've got a building already, but over the last couple of years, we've moved every bit of machinery around in that building. We've extended the building. We've got a new building coming, which you can see just behind me. And we've planned all of that in VR. So we literally make a life one-to-one scale size model, and we'll put our technicians and engineers in that model with a VR headset so that they can walk in between the machines and go, yeah, this space here feels about right. I can reach into the machine tool. I've got my workbench here. I know where everything is, and you can test out new layouts before you have to actually move anything. And then you've got augmented reality, which you know, brings the real world around you into view, but augments it with extra information or, you know, models, you know, 3D visualization, so we can give work instructions to someone. They can physically see, you know, inside a machine. They can see through walls if you want them to. So I mean, it's all about again, reducing cost and getting benefit and efficiency, and we can do that using computer game technology, and it makes the work environment a bit more fun, because you can just take a break and switch to a game where you're doing archery, and then you flick back and you're looking at pipe work inside a wall. So there's huge amounts of opportunity within visualization, and AR, VR is just an aspect of the technology that we use.
That's really, really fascinating. I know we are running over a wee bit on time, so I'm going to put this last question to Graeme. What advice would you give to someone who is looking for a career in engineering?
Easy question.
I
Well, I said before, I think the first thing you need to do is identify the thing that you're passionate about. So if that's if that's designing, then you might want to think more about the types of qualifications you're going to need that will help you do the design stuff. So whether or not that's looking at what your hires or nats are going to be. If you're thinking then about college and stuff, then you want to think about, again, the types of college qualifications that can support that. And likewise, apprenticeships are a great route to get into manufacturing. They're a great route to get into a lot of careers, and sometimes actually the best route, because it gives you a chance to, actually get hands on the job and learn as you get paid and learn as you develop, which is fantastic. Like I said, it's all about finding the things that you're interested in and passionate in. And once you begin to identify those things, you start looking. The internet obviously is a huge repository of information for all these things, but likewise, it's a great repository for finding out about types of opportunities. So start looking at what colleges offer, start looking at what universities offer if you're at that stage. Or speak to maybe someone in your family who might have a job like that. There's always people who are about, who've got some experience that you can rely on, and you should never overlook that. I think I did when I was younger, and didn't speak to older people enough to see what their actual experiences were, and just tried to do everything on my own. But a lot of people out there can help you, and even if that's, again, like I said, your careers advisor in school, if those are available to you, then that could be a really good starting point for you as well.
I think that's some really good points to raise there. And jumping off of that question, I'm going to bring us into the wrap up, because by just attending a session like this, you guys are already opening yourself up to opportunities and experience that can help you get a career in manufacturing. And you can find out so much more information on this sector on the My World of Work website. You can see it on the screen just now. And for many more information on apprenticeships, go to the apprenticeship.scot website. But yeah, I really hope you guys enjoyed today's session. If you've got any questions about today's career, please get in touch with your school careers advisor, as they'll have a lot of information to give you and guidance for you. And if you really want, you can get in touch with us. I'm sure Danny and Graeme would like to hear from you guys. But this session, as we said at the start, has been recorded, so you can watch it as many times as you want at a later date. Hope you guys have a nice day. See you. Thanks for the experts showing up today. Really appreciate you guys.